Riccardo, the stage is yours.
And okay, good. Hi everyone. Thank you for joining this talk today. My name is Riccardo Freschi. I'm a solution architect at AWS. I'm here today to talk to you about, well, the title is there, event-driven autoscaling for Kubernetes workloads using KEDA and Prometheus metrics. So, just a very brief introduction about my job, because that leads to the rest of the talk. So as part of my day-to-day work, what I do is helping customers and partners adopting the cloud. And to do that, we actually address, myself and my colleagues, we address problems and different architectures, solutions, designs that colleagues, customers and partners share with us. And some of these, well, solutions that we help them with end up in some repository that hopefully people use as a reference as well, or a starting point, some base to do some further work. This one, which is a repo, if you want to take a screenshot of the QR code, you can follow later basically what I will be doing today, what I will be showing, and you can repeat if you want to all the steps in order for you to get to know a little bit better KEDA and event-driven autoscaling. Okay, that said, I will start. So basically what I will walk you through today is basically this cluster where you can see that KEDA is at the heart of it. So, let me start first with a short introduction about what KEDA is. I'll do I'll handle a very few words on it. And if you want to know more a little bit, there is also a good podcast from a colleague that did a keynote today with actually the KEDA inventor. So KEDA is an event-driven autoscaler. What that means is that it is able to look at events through some sources. These sources can be anywhere within the cluster or outside the cluster. So, for example, this is very useful because you don't need to look at Prometheus metrics. We will be using that today in that way, but it is useful to know that actually KEDA can source metrics from external sources. It could be, for example, within AWS, for example, the cloud, or anywhere else, any other service in other cloud providers or wherever. And I will be explaining to you a little bit what these sources could be. They are called scalars, by the way. The other point where I see KEDA is very useful and excels is because it can scale to 0, which is different from the HPA, horizontal pod autoscaler capabilities. HPA is limited to a pod count of 1. So what KEDA does is basically it's a intermediary between the scalars and the HPA controller, because what it does, it exposes some metrics which could be, you can configure. They can again be taken from these scalars that can be of many different types, coming from within the cluster or outside the cluster, and then produces an HPA object that the HPA controller will monitor as usual, like you probably know, and will, by looking at the metrics and looking at the HPA resource, will decide if the pods should be increased or decreased. HPA will go down to 1 replica, so down to 1 pod, and then if it needs to go to 0, or from 0 to 1, if we are scaling out, KEDA will intervene, so we'll get into onto stage, and we'll use the sub-resource, object sub-resource that within the Kubernetes API that will allow it to basically bypass the HPA, so the HPA controller, and actually scale from 0 to 1 or 1 to 0. So a very brief overview of KEDA. Now, let's have a look at this cluster so I can explain to you what I'm going to show you. I will do a demo today of a sample application, a very basic application. It allows me to basically expose as an API, an endpoint, and just returns some sort of hello world. This is the sample application that you see as a deployment on the far left. And we will see this application growing the number of pods. Because what I did is I artificially created a metric, which is a very bad metric, because it just exposes the sum of all the HTTP calls that I'm doing. So it just increases, always. And what I will be doing is basically I will be increasing the number of APIs that I'm going to call. So I will be called this multiple times. And the metric that it exposes will go through the Prometheus, which I deployed with the Kube Prometheus stack. And that will be exposed by KEDA into the aggregation layer. So a few words, I will say a few words about the aggregation layer in a minute, but basically what this loop will do is that whenever I will be calling the API, the exposed matrix will increase continuously, linearly, and therefore the HPA, which we will be seeing this metric increasing, will increase also the pods. Pods are deployed on our cluster. So how our cluster is made is you can do whatever you want if you want to replicate this, because every component is open source. What I used is AWS, the AWS cloud, and specifically Amazon KEDA with a lot of managed components for me to make it quicker. So for example, in my KEDA deployment, I have Carpenter. Carpenter is deployed within the AWS account and managed by AWS in KEDA auto mode mode. You can also, if you want to, if you are using your own data center, or if you are using another cloud provider, you can deploy Carpenter on your cluster and run it on your data plane. What Carpenter does is, I'll do a very brief introduction on that. It's basically a cluster autoscaler. We need the cluster, we need the cluster autoscaler because once our pods will increase, we need to actually scale out also the data plane. At the moment, we only have 3 nodes, and I will show you here. Hopefully you can see a little bit. Top left, I am using a, let me actually, it's repeated twice. So KEDA node viewer, there you go. So the summary is at the top, and we have 3 nodes at the moment running. You can see the load is not very high. Hopefully you all can see the screen. If someone is not seeing, yeah, just let me know. And on the right, we have this single pod that is running. Okay, so this is the pod, status is running, and that's our application. We'll see that it will be increasing later. So, what I was saying is that we have Carpenter. Carpenter is helping because as a cluster autoscaler, it will increase the number of our nodes, because when we will be increasing the number of pods. Some of them will not have space to run. So they will not be able to be scheduled. And therefore, they will stay in pending state. And this is what Carpenter is looking at. It's looking at pods that are in pending state. And whenever there are pods in pending state, it will react and call the EC2 Fleet API. The good thing about Carpenter, between the many, is that it can actually act very granularly. So it doesn't need to have node resource groups where you define the nodes with the same features, with the same set of parameters, but instead you can configure Carpenter with a number of parameters. And for example, you can configure it in this way with two CRDs, custom resource definitions, which are the node class, where you can define the AMI in the case of AWS, which is basically the image that is running in the node, some other parameters, and you also can define which configure that, so it, for example, will request only instance families and instance sizes within those parameters. Also, you can configure architecture and a number of other things. But basically, Carpenter will be, once you configure it this way, will be able to make an analysis of what is available, the simulation of the costs as well, the resources required, and will take decisions. So it will request in our case, the EC2 Fleet API, which instances and how many instances to request. So this is as for Carpenter. Just a few words on how this actually works in terms of, well, the workflow, the life cycle of these nodes. Carpenter will create a node claim, which is a custom resource again, that reflects the life cycle of the node. This is to monitor what's happening. So I'm requesting a node, the node is ready, the node is provisioned, it is in our cluster, it is not in our cluster, and now it is registered in our cluster, so it is active and can host pods. So this is more or less, from a high level perspective, the story. This is in relation to horizontal node autoscaling. Again, the capacity, the compute capacity that we need to provide to the nodes, to the pods in our cluster in general, so that pods can be scheduled. Very quickly, the repository uses Flux as well, so I deployed Flux so that we can use GitOps and deploy our resources. Okay, so maybe HPA. Before looking at the HPA, we can look at this, which is actually the custom resource definition that KEDA, the main one, I would say, that KEDA leverages in order to drive HPA. Like I was saying, KEDA is basically some sort of pipe, transformation between exactly this scaled object that we define, and then it translates that into a horizontal pod autoscaler resource. That is something that we create, and this is something that it creates. So in there you can use, you can define, like I said, the minimum replicas, maximum replicas as usual, and you can have the different triggers. These are the scalers that I was mentioning before, and like you can see, you can have some very traditional triggers like the CPU utilization, but you can also use a RabbitMQ and a Prometheus trigger. What KEDA does is basically it takes this, it looks at this, and translates that to to an HPA resource. It also exposes, like I was saying, our metrics in here. So as part of the control plane, in my case, it's done by a K8s, but you can enable that on your own cluster as well. You enable the aggregation layer. So the aggregation layer expands the Kubernetes API. And in this case, well, we can expand it to expose metrics. This is pretty much standard. And we have, in fact, the usual metrics that we expose generally are CPU and RAM, the ones that we generally look at, and they are exposed, proxied, I would say, from the metric server. The metric server, in my case, is deployed by EKS out of the box, but just remember that you need to deploy that manually if you want to do it on your own, on another cloud provider. So metric server is delegated the metrics API, like you see there at the top, and then the other two are actually exposed by external metric servers. And in this case, we are using KEDA, so KEDA is proxying the external metric server and serving our metrics. Therefore, in my configuration, I am telling KEDA also to look at which metrics, where they are, with the trigger. So for every scaler that I have, that I want to configure, I tell KEDA which metrics to look at and how to expose them in here. From there, it will be the HPA controller that is running within the control plane to look at them, look at the configuration of my HPA resource, make a comparison, and see if the metrics are too high. It will increase the number of pods, which will happen in my, hopefully, in my demo. Just because we are looking at it, generally the metrics that KEDA exposes are prepended with S0, which stands for scaled object, just for avoiding naming conflicts. Okay. So let me see if maybe very quickly, I will show you, just as a recap of how actually this generally works with the scaling of the pods and specifically HPA. The algorithm that it uses is this one. So the desired number of pods is given by this formula. So it is looking at the current number of replicas, and it is looking also at the current metric value and the desired metric value. And then the ratio is multiplied by the current replicas, so that if we are our metric increases above the desired metric value, this is greater than 1, and so we will go above the number of the current replicas. Just to give you a few numbers, what we will be using is as figures for our metric values and max values. So we will have a number 10 max number of pods. So we will increase the number of the pods up to 10, and that's it. This is the maximum. We also have a target of 2. So this means that if we have an average value of the sum of the requests on our application, HTTP calls, that is on average higher than 2, then the HPA will increase the number of the pods. This is defined by our scaled object. So again, what I will be doing is I will call 30 times this HTTP endpoint, so that, divided by 10, which is the maximum, will give me 3. 3 is greater than 2. and therefore the number, this is good, and so the number of the pods will be increased. Okay, let me see. Well, here I have another, just as a few more examples of external scalers, so not within, that could be running outside of our cluster, but also within our cluster if we have deployed Kafka within the cluster. But for example, if you're using Kafka as a managed service in AWS, that will be external. So you can also have Redis. You can also use databases. So you can actually connect to a database and actually make a query, define a query, and the query will return a result, and that will be your metric for comparison. AWS SQS is a managed queue service. Again, that could be used as a scaler. Okay, I think I have explained the full flow. See, yeah, okay. So I think we can go to the demo now. So I've already, okay, so let me show you. I will be flipping a little bit, okay? So apologies if you need to pay a little bit more attention. Okay, so this is a Grafana dashboard, HPA, that I deployed in my Grafana, because Grafana is part of the Prometheus stack. I've already logged in, port forward, and I'm accessing that now from my laptop. You can see here that we have current replicas is 1, max replicas is 10. So like we configured. And later what we will see that there is an increase following our increase in the number of HTTP calls. Let me make it a little bit larger. Okay. Hopefully not too much. Okay, so I have a little bit of a few snippets in here just to make my life a little bit easy. You can see the 3 nodes here. This is a query to actually ask for the number of the nodes running and the type. You can see, well, those are AWS instances of nodes. Let's have a look at the metric now. So I'm pinging the aggregation layer, the external metrics. You can see in here, okay? And we have a total value of 0, so no requests at the moment, because I didn't ping my application yet. Already ported port forward. Now I will be calling my application. Hello from the example application at the bottom. Hopefully you can all see that. So this is the first call, and we will be actually inspecting the metric exposed again, and now it's 1. So good. So far so good. Now what I will be doing, I will be calling, like I said, the endpoint 30 times, because I want to go above the metric thresholds, which is 2, all the maths we did. Okay, so now we need to wait a little bit, hopefully not too much. And you can see now that we have running pod created. You can see also that the resources there are getting exhausted. You can see that there is 1 pending pod, more pending pods. And you can see that now we have a new node in there. You can see the process that they are going through. More pods, because we needed to get to 10. Now we have 10 pods, and they are container. They are going through the process of basically creating. And that is basically the action that Carpenter is taking, and this is the action that KEDA and HPA are taking. We are close to the last pod. All of them are running, and that's the final number of nodes that we need that have been created by Carpenter. Of course, when you, in your production and your designs, you will be using different metrics, but you can the metric is not relevant. So whatever you choose, it will have the same effect. Good, I think I am done. And that should be it. Oh, maybe just a final word. If you can please do a quick survey. This is really 2 tabs. It's 2 ratings, just for me to improve where I can. So it's 2 ratings, which are basically related to how was the presentation today, and an optional text field. If you want to leave some feedback on anything, really, that would be nice. That's it. Thank you very much. Thank you.
I think you'll get only high numbers. Like that was an excellent presentation. Autoscaling is always a great topic. Any questions?
Yeah, thank you very much. Great presentation. I really like the style, like, you know, single slide deck. Awesome. I have a question about Carpenter. So the synthetic sample looks great, right? But in reality, not like worker node provisioning could be time consuming, right? And in this example, you had like linear. What happens if you have like spikes? For example, like let's say Alexa, and it's very like time driven. For example, in the morning, you have a lot of requests like 8, 9 a.m. when everybody say, Alexa, hi. So a lot of requests going there. Would Carpenter be able to handle this like in a way that there is huge spike, a lot of workers need to be provisioned immediately?
Okay.
Wouldn't it choke?
So I think here we've seen a end-to-end scaling. So it starts from exposing the metric. So the first thing that you need to have is your workload exposing the metric immediately. And then the flow. So with what frequency the metric is exposed then to the aggregation layer, which is configurable. And then the number of the pods and the HPA need to react, so to increase the number of the pods. Carpenter will enter the game only when there are pending pods. So at that stage, I've seen good performance. So it's not something like you need to wait. And you also need to consider the availability of the resources that you're requesting. For example, if you're requesting GPU instances, it might be that actually there are no GPU instances available in the region you've chosen. So I would say that generally Carpenter for the node provisioning is fairly fast. It depends on your flow.
Right, but my take is that so if Carpenter reacts only on pods independent state, I mean, it's too late in some cases. So I'm wondering, for Carpenter, would it be possible to do the like predictive scaling? Let's say at 8 a.m. Or like at 7 a.m. I already need a few more workers to begin in advance.
That's not auto-scaling though.
Yeah.
This was auto-scaling. Okay. Yes,
okay.
Anyway.
Cool, thank you.
Thank you, Riccardo. Great presentation.
Thank you.
Yeah, it was amazing. Just quick question. I saw that you have created one scaled object and there is multiple trigger, right? So how KEDA will know that?
The
What is
maximum.
the precedence, right? So, okay, CPU is 50%, it goes down, let's say 20, so it should be scaled down, but we have a lot of requests. How KEDA will manage that? So it's really hard to that. So if you have created multiple scaled object, okay, easy. Well, we have a one scaled object and multiple triggers. So this is.
It computes the number of pods that need to be allocated and picks the largest one.
Thank you. Thank you.
Yeah, to the question, yeah, great presentation as well. I really enjoyed it. To the question that our friend asked, do I understand it correctly? For example, let's say if there is a 10 seconds of like spike for the CPU to the 90%, is there a possibility for the KEDA, let's say, it checks if this spike goes on, just saying like 30 seconds, in that case it will trigger? Is there any option?
I think you can manipulate that with, in the case of Prometheus, with the right Prometheus query.
Thank you.
Any more questions? So, a big round of applause.
Thank you.